Hi, everyone. So this is the June project update, and to introduce myself, my name is Hongbin Lu. I'm the first PTL of this project, and with me is Su Mutos. He's a June code reviewer. And so first, a brief introduction of these projects and what is June. So June, by definition, is an OpenStack container service. And what it means is it provides an APIs for you to run the containers in an OpenStack cloud without creating any servers or clusters. So in June, a container is just like a VM, so that you can use the APIs to get you the containers, and it connects to the neutrons, and it can attach a single volumes, and each container is belong to a keystone tenants, so that you have the keystone multi-tenancies. And a slightly different from the VM is that we are deploying image directly from the Docker Hubs, which is don't like the VM that you need to download the image and upload to the GANs. And so why we create these projects? And this is because, so suppose this project is not theirs, and what are the options that's available for consider basic scenarios that you have a container image and you want to run it to the cloud, and what are the options? And possibly the first option is you want to talk to Nova to get a VMs, and you configure the VM to install the Docker daemons to host a few of containers. And this is good, but after that, you need to manage those VMs and manage all the containers that are running in the VMs. And the second option is similar, is that you also need to provision a set of VMs and install a container orchestration engines, which we call the COEs, on top of those VMs. And the API of the COE, such as Kubernetes, is very powerful. And later we will talk about how to integration with the Kubernetes so that you can get the benefit of both. But eventually, you also need to manage those VMs, and you also need to manage the orchestration platform that is running on top of the VMs. And all these things has benefit and capacities, and you may or may not want to do. So we think that there's a lot of scenarios that you just have a few containers, and you just want to run it in the cloud and in a single command or two, or without any additional step to create the VMs or create the clusters. So we think it will make sense to create a container service in OpenStack so that it can bring the container to the top level resource and make it available as a part of the OpenStack APIs. And we expect that you can either directly use the APIs to get a few containers, or you can use it together with other high-level orchestration service so that you can use orchestration engines, use the API of your orchestration engines to provision the containers and manage the containers. And so this is some scenarios that we think it fit into the June. For example, the CI/CDs and batch processing, and maybe host a few applications, or any other scenarios that you just want to get the containers and you don't want to provision a whole COEs. You don't want the heavy job to do the provisioning. And so if you use June, you have several benefits, such as you create a container, there's no servers, and you basically push the management of the servers to the cloud providers and let the cloud provider to manage those servers, and you can just focus on your applications. And there's several other benefits that is provided by the June. But if what you want is some advanced scenarios, such as how to do the HA deployments of your applications and how to do the rolling upgrade, how to do the auto scaling, then what you're looking for is an orchestrators, such as Kubernetes. And we make it we try to avoid to implement all those features that is already implemented in the orchestrators, and so that we don't need to re-implement anything. But we are looking for to integrate with the orchestrators so that you can get the benefit of both solutions. So the first example of using Zun with the orchestrator is using with HIT. And HIT is the OpenStack orchestration service, and it allows you to use a single template to define the topology of your applications and how the set of resource and what is the set of resource you are going to use and how to connect those resources to deploy your VM-based applications. And so with Zun, you can do the same thing for the containers. And you can define the topologies that consist of the containers and how the application is deployed to the containers. And the second example is Kubernetes. So in this case, what we are doing is basically to implement what we call a connector to the Kubernetes. And it allows the Kubernetes to schedule with some of the pod to the OpenStack Zun service and let Zun to take care of the provisionings and management of the containers. And there are several scenarios that we are going to consider in here. So in the first scenario, it's just like the traditional approach, and you have Kubernetes clusters that is on a set of VMs, and you want to run the pod on the VMs, and which is like what you normally will do in OpenStack. And in the second scenario, that is opposite. You want to take the serverless approach and get rid of all the VMs and have Kubernetes to provision all the pod in OpenStack Zun. And depending on your use case, you might use to choose one approach over another. But what we think is the most interesting scenario is what we call the bursting scenarios. And in this case, it's just like to mix the pattern of all the two approach we mentioned is that you have a Kubernetes clusters and it's based on the VMs, but you use the Zun as a kind of additional capacities for the Kubernetes clusters. So the reason you might choose to use the containers over the VM is that the container to give you the ability to patch your application that's more density so that you can maximize the utilization of the machines that you are using. But in reality, what it ends up happening is that you are either over-provisioning the set of VMs so that you have some space for the additional capacity that is for the workload that is not planned or unexpected, or you can deal with the time that is going to take to spin up the additional VMs and configure the VM to join the Kubernetes clusters, so you have the space to run the containers. But what are interesting that you are using the Zun with Kubernetes is that it allows you to address the problem of over-provisioning so that you can just provision the set of VM for your workload that is stable, and you can burst the additional containers to the Zun so that it can provide the extended space for your Kubernetes clusters. So this is how it's going to work. So by default, the Kubernetes is going to schedule all the pod to the VM-based clusters, and until it uses all the capacity of the clusters. And then the Kubernetes is going to pull out the API of the OpenStack Zun and schedule the additional pod to the Zun. And the pod in different locations is abstracted by a Kubernetes service, so that the Kubernetes service is basically routing the traffic of the container on different locations and expose the same IP address to the end users. So this is the list of features we are implementing for the queue cycles. the first feature is the Cinder integrations. It allows you to launch a container and attach it to the Cinder volume, mount the Cinder volume to the file system, to a path in the file system of the containers, so that you can store the data in the path and it persists to the cinders. And we implement a container group, which is basically an implementation of the Kubernetes pod. And we implement the PCI pass-through and SRLV, which is for the NFA use case. And we support the integration of the Key container as an additional runtime for the runcs. We have the Cloud Shell, which is the UI features. So in the R cycle, we are going to have the Kubernetes integration that is complete. And we are going to implement the integration of the Kata containers. We are going to implement the quotas, which is for you to limit the number of containers on the tenants. We are going to do we have implemented the container rebuild, which allows you to delete and recreate the container with the same IP address and same Cinder volumes. And we have the availability zone API so that you can list a list of availability zone and schedule a container to a specific availability zone. So look beyond the R cycle, we have several features that is planned, such as Cinder volume multi-attach, so that you can share the Cinder volume for multiple containers. And we are going to plan the notifications and so that we notify the event of the containers. And we have the monitoring of the containers. We are going to integrate with the Pacement APIs and possibly maybe implement the vGPU support as how they implement in the LoRaWAN. And this is a list of resources for how to contribute. And we have IRC channels, and we have the weekly meeting that's scheduled on the IRCs. And there's a few links that contain more information of this project. And then Sue is going to show a demo.
Yep.
Ready?
Okay. Okay. I'm Shumuto from NEC Japan. I'd like to show you the features of Queen's release. First, we added new options for container creation. Let me introduce new options while creating a container. Specify the busybox for image and set command sh, then switch to the spec tab. We added hostname and runtime parameters for container creation. Okay, hostname is the hostname of this container. Runtime is to create container with. We can specify the runtime which is supported by Xen Compute. Default value for runtime is runc. Also, auto remove option is added in Xen UI. This option added as one option for exit policy. And we added volumes tab for mounting volumes on the container. We can specify volumes from existing available Cinder volume or specify volume size for new Cinder volume creation and specify mount point on container, then add volume setting into following table and create container. Container will be created soon. Next, we added the network tab for attaching or detaching network to update action. We can see the attached network for this container in allocated table. To attach the second network to this container, select it from available table and update. The container will be updated, then second network will be attached. Next, we added new action, stop and delete container. This action stops the container before deletion when the container is running. Previously, our UI showed all of the actions regardless of container status. But now, our UI is filtering the actions according to its status, just like what instances panel does. So we cannot find unpause action for running container. Next, I'd like to show you a unique feature of Zun UI, Cloud Shell. Cloud Shell enables to execute OpenStack command from Horizon. Zun UI creates Cloud Shell container for the user, like this, and gets user's Cloud YAML file from Horizon, then set it into the container. Zun UI does not set the user password into the container, so user should set manually OS password environment variable or add password line into Cloud YAML file. Now, user can execute OpenStack commands. I will show you a super simple use case. I'd like to confirm volume and second subnet name on the container that I created a few minutes ago. Run OpenStack volume list. We can find the volume newly created a few minutes ago. By the way, we can find IP addresses for this container on this container details view, but we do not confirm subnet name on this view. So let's check it using Cloud Shell. So let's copy subnet ID and run OpenStack subnet show for the subnet ID. Okay. We got the subnet name private to subnet like this. Using Cloud Shell, we can operate all of the features what OpenStack client has, even if dashboard does not have yet. That's all for me. Thank you.
Yeah. Any questions?
Fantastic.
Yeah.
I think this is going to get the containers as the top level in OpenStack.
Yeah.
And question to you, you were using run C, whereas you were talking about kata. Are you using run B or run C? Is there any difference for Docker and kata?
So in Docker daemon, you can specify an option. That's called the runtimes. And we are basically passing what you have specified to these options. So if you want a kata, you specify the runtimes as a katas. So that we schedule the containers and launch a kata runtimes with the containers.
Just one more, trying to understand this. So you have overlay of container network on the underlay VM network and underneath that physical network. So are we seeing 3 layers of networking here in this?
All the container in Zun is connect to the same network as the VMs. And so yeah, in the VMs, you have the tiny networks, and in Zun, that's similar. All the containers connect. You can specify the network that you want to connect, which is much the same as the VMs.
And if the other way around, if you do containers, VM within containers, which Red Hat is talking about, does it make sense?
From your end user point of view, you don't care the container is running on the VMs or bare metals, and what you see is just the API to run the containers, and you don't feel where the container is running and what's the node of the container. That's hidden. Those are hidden details.
Thank you very much. Very great, wowing implementation, I would say. Kudos to you.
Thank you.
Your team.
Thank you.
Is Docker the only container engine you support? You do LXC, LXD?
Right now, Docker is the only container engine we are supporting, but we are defining an interface for the drivers so that if there's an additional container engine that is going to come in, and you just implement the interface we are defining, and it should work.
And for your Kata containers, they support hot plugging of networks. I think today you're using Courier. Are you going to support native hot plugged multiple networks with Kata, or are you going to continue to use Courier?
So couriers, you can also do the hot plug, right?
Right, but it's all through one port, right, into the container. That's what Courier supports, or provides, basically, to Docker.
So in couriers, it implement the container networks, container network models. And I think it allows you to have multiple endpoints of the same containers. And the endpoint is one-to-one matching to the neutron port. So I think it implements, actually I'm sure it's supporting to have multiple neutron port, to put multiple ports in the containers. And
The original way they implemented that is through a trunk, right? So you had one trunk going into the Docker container, and the neutron ports were basically like VLAN in over that one trunk port.
we are not going to use a chunk because we are not running container in the VMs. We are running container in the bare metals. So what we are doing is same as a NOAA's, is that you specify the port and I do the port binding, and that's it. And we are not, I haven't tried to use a chunk with the Zun yet, so I'm not sure about the chunk.
I can talk after, maybe clarify.
Sure.
So just to build on the gentleman's question, so if you use sorry, okay. So just to build on, okay. So if you don't use the Kubernetes orchestrator, you're not needing any sort of overlay network to connect all of the containers. Is that right?
No, we don't.
Okay.
So-
but if you do, can you still use the neutron just to connect them, or will it be automatically there'll be an overlay if you use Kubernetes?
So right now we are not doing the overlay. So
Okay.
I'm not sure. And until somebody come and say I want the overlays, then we look at how we are going to do that.
Okay. All right. Thanks.
Yeah.
Thank you.
Okay. Thank you.